Welcome to this ATA Insights webinar. Thank you for your ongoing interest and support of our webinar program. Today's session will begin in 2 minutes. ATA Insights Webinars is an online platform for the dissemination of professional renewable energy knowledge across international borders. Our aim is to democratize access to information, for innovation to spread faster, and to make the industry more competitive. And we do this through our online sessions, open to all our members. Every year we do more than 100 sessions with over 250 speakers, 50,000 attendees from more than 50 countries. To participate in the session today, use the chat on the right-hand side to introduce yourself, your company, and where you're joining from. Under the screen you will find the Q&A box, where you can send your questions for the speakers. We will get to as many as we can today. We're recording this session and we will send you a link to the materials in a few days. Please consider supporting our content creation for the webinar program. Contact us on the email on screen.
Hello everyone and welcome to today's online session, which as you can see on screen is on the role of acoustics in enhancing BESS performance and longevity. So today Sharon Santhosh from Wärtsilä is going to be telling us all about this interesting topic. Sharon, before we get started with your presentation, could you briefly introduce yourself?
Absolutely. So hi everyone. It's a pleasure to be a part of this webinar, and I'd also like to take this opportunity to warmly welcome you all. And I also would like to thank Carlos for the kind introduction. But again, just to briefly introduce myself, my name is Sharon Santhosh, and I am currently working as an application engineer for Wärtsilä's Energy Storage and Optimization division, where my role is primarily focused on acoustic management. So yeah, I'm super happy to have gotten this opportunity, and I look forward to an insightful session.
Brilliant. Thank you, Sharon. So just, a brief reminder before you get ready to share your screen, Sharon. So we are, this is a reminder to those in the audience. So we are recording this session, and you'll get an email with the video recording and the presentation as well. So yeah, over to you, Sharon, whenever you're ready. Remember, by the way, for those of you who are in the audience, that you can send in your questions using the Q&A box. And I can see that lots of you are introducing yourselves using the chat. Keep on doing that. That's what it's for. So thank you. So, okay, I can see your presentation on full screen, Sharon. So over to you.
Okay, so great that it's all working. So thank you everyone once again for joining. And today I would like to briefly shed some light on a very high level as to what is one of the burning questions that is currently being asked within the BESS industry, and that is all about noise. So today I would like to talk about the role of acoustics in enhancing the performance and lifespan of BESS systems. And before I get started, I would like to sort of go over the main objectives today. And essentially, I've divided the agenda for today into 4 points, whereby first I'll be exploring the broader impact of acoustics within the BESS industry. So why exactly is noise important, and what exactly does it entail? And then we'll be looking into some of the sources of noise that are that comprise the BESS industry. We'll then go into the specific effects of noise in terms of efficiency and safety. So we'll be looking a little bit into performance level effects as well as component level effects, and how noise mitigation and noise control is absolutely crucial when we look at any system level performance. And then I will wrap it up with some of the solutions that we can use and that the industry does use for noise, noise mitigation. And ultimately, by the end of the session, I will also sort of give a sample real-world case scenario, an example of sorts of what this would look like in practice. And ultimately, my objective or the aim is to highlight why exactly acoustics should be a major design consideration during the BESS planning and performance procedures. So to deep dive into the topic, so I want to first shed some light on why exactly noise matters in energy storage, because when we think about BESS performance, noise is typically not one of the first things that would come to our mind, but noise is a byproduct of almost every single operational process that constitute a BESS system, and it affects multiple areas. And one of the first, and I would say one of the most important areas, is definitely the system performance, because high levels of noise often indicate that there could be some inefficiencies with the cooling or with the electronics that are involved, even maybe the components, which again we'll be looking briefly as we go by the slides. And poor acoustic control or noise control, it can lead to component degradation and reduce lifespan over time. And thereby it becomes very important that we monitor and manage the noise so that we can identify what exactly is this problem and how we can potentially resolve them in the early stages, so that we can not only save on operational and maintenance costs, but we take a more proactive approach to ensuring that the system is quite reliable. We also have regulatory compliance. Now, many regions have very strict noise regulations, and now the BESS installations must comply with all of them. And ensuring that these noise levels are within the permissible limits is absolutely crucial, because if we don't look at the regulatory requirements, it could lead to project delays, potential fines, penalties, and in the worst case scenario, even complete project shutdown. And that is something that we would like to try to avoid as much as we can. We also have the impact on community, because BESS installations, they're often located near residential areas, commercial areas, and even industrial areas. So high levels of noise can lead to complaints, and essentially it will create a negative perception into a sustainable solution such as this. So if we manage acoustics early on and paint a positive light that even though there are such heavy equipment and machinery running nearby, it is still, within reasonable limits, and it's not negatively impacting anyone or anything, and it helps to maintain a good relationship with the local community. We also have health and safety as one of the important factors, because continuous exposure to high levels of noise can lead to significant health issues, not just for the communities living nearby, but also for people who are working on the site. And it could lead to an increased risk of accidents. So ensuring that the noise levels are kept within the safe limits of operation becomes absolutely crucial for the health and comfort of everyone involved. We also have what is known as market competitiveness. So now we're seeing the rapid increase and rise of the BESS market that is growing across multiple regions. And now because of that, customers are becoming more discerning. They're able to differentiate between the overall impact of all of these systems, and that also includes noise pollution. So BESS providers who do manage to integrate effective noise mitigation strategies, they do tend to have an extra edge, which allows more reliable, compliant, and community-friendly solutions, because this is one of the questions that we ourselves personally have been asked in almost every single project that comes our way at this point. It's become a standard question as to what is your approach to the noise topic, or how exactly does the noise levels look like for what your product is offering. So it becomes of ultimate concern for us that we address this as soon as we can. And then lastly, there's also the impact on environment. So uncontrolled noise, in many cases, it can disturb the local wildlife and ecosystems, especially when we start installing these sites in more sensitive environments. So we have to make sure that we don't try to overstep our boundaries, so to speak, and negatively impact not just the people living nearby, but also the wildlife that surrounds these regions. So a combination of all of these factors in a way highlight why exactly noise is more than an annoyance. It's not just a cause for stress or concern, but it ends up becoming a proper technical and a strategic challenge. So now that we know why noise is important, the next step is to definitely identify how exactly we can mitigate it. But in order to know how to mitigate it, we first need to know where exactly the noise comes from. So I would like to classify this into three main points or three main sources on a very high level. So the first one being electrical sources of noise. Then we also have mechanical sources of noise, as well as structural sources of noise. And these sources can then be attributed to different equipment and components. So electrical sources of noise primarily constitute inverters and transformers, because these power electronics, they tend to be more dominant in terms of noise from an electrical point of view. So the inductors that are present, the IGBTs that are present, they can all generate high frequency noise, electrical noise that can interfere with other equipment and reduce efficiency. So the type of mitigation strategy that we would take in order to address an electrical noise would be much different from, let's say, the mechanical sources, which then constitute what forms as the HVAC systems, the cooling systems, the fans, so on and so forth. Because these mechanical sources, I would say, are more dominant in the battery enclosures themselves, because when we look at battery enclosures, one of the primary need is thermal management and the cooling system to avoid overheating issues. So if the system is not designed properly, then it could lead to overheating and the fans operating at a higher capacity than it needs to. So the type of mitigation solution that would then be required for this kind of noise would look much different. Similarly, we also have structural noises. So if there are any components inside the enclosure that are not mounted properly, or if there are any loosely placed equipment, then the components can then end up vibrating and during its operation, and this vibration translates into what is known as vibroacoustic noise, or noise that generates from vibrations. And as a result of this, there will be a persistent noise, which again, if unmanaged, can lead to efficiency issues and even compliance issues, because they can also be quite audible and quite dominant as well. So overall, the type of sources of noise in BESS systems indicate how exactly we need to tackle the noise topic. So now that we know what are the noise sources in BESS, the next thing is to identify how exactly the noise impacts specific components and performance, because we have a multifaceted approach every time when we talk about noise. And a lot of the times people think about it only from a performance level, which is absolutely true. But in many cases, there's also a significant effect on the components itself. One of the first and major points which I would like to raise up is definitely the thermal management, because excessive noise is often an indication of issues with the cooling systems, such as, let's say, the fans or the HVAC units. And in many cases, if they're not designed properly or if they're not mounted properly, it could lead to airflow disruptions and it can lead to a lot of turbulence. And as a result, there could be inefficient cooling, and it could thereby again lead to a lot of thermal inefficiencies, such as overheating and thermal runways. So the fans again would be operating at a higher capacity, and as a result, it gets overheated and it becomes a vicious cycle of it operating in its full capacity, and then having to compensate for that over maximum power. So as a result of this, it can lead to a faster degradation and a faster wear and tear on the HVAC systems and the units themselves, which is one of the key components when we're talking about BESS systems. And a lot of the times, the thermal management and noise management do end up going very much hand in hand together. So they're quite complementary to each other. So even when we are targeting noise reduction strategies, there's only so much we can do without it affecting the thermal systems as well. So if you're able to design an efficient hardware system from a cooling perspective, we are able to target noise in the early stages of development itself. Secondly, we also have ecological factors, and what this entails is basically the disruption to wildlife and also community impact, because noise from BESS systems do affect wildlife, because in many cases, animals do rely on sound themselves to communicate with one another, to navigate the area. And if there are BESS sites in highly populated areas, or if there are high noise pollution areas, it could really unintentionally interfere with these communication that is established by the local wildlife. And as a result, there's going to be a big imbalance and a disruption to the ecological system itself. So that again leads to a lot of issues, which also is now becoming more and more of an environmental concern. We also have community level impact, because again, the high levels of noise, it can lead to potential conflicts, and also not just from an annoyance point of view, but also from a health point of view, because it can lead to a reduced quality of life, because over time, noise does have a physical impact on our bodies as well. So we can be subject to hearing loss, or we can be subject to psychological issues and even cardiovascular issues over time. So it becomes absolutely important that we address noise from this perspective as well. We also have logistics. So what this again would be entail is essentially the site selection and planning. So when we're looking at a BESS installation, a lot of the times the noise levels must be assessed to ensure that they're compliant within the local regulations and the limits that are present by those regions, so that we can minimize the disturbances to the nearby communities. So again, if noise is not addressed, it can potentially lead to having to choose an alternative site layout, or maybe even longer transportation routes. And as a result, it can lead to a lot of additional costs if a quieter location is needed. Similarly, now again, with the rampant growth of BESS systems, we're seeing a change in zoning laws. And because of that, a lot of these BESS systems are moving closer to residential and commercial areas, or I should say highly, or densely populated areas. And the noise limits for these kind of regions would look much stricter and compared to rural areas. So when we are looking at extremely strict noise limits, at the end of the day, these are all equipment which are also operating at a certain level of capacity. So meeting those very strict noise limits can get quite challenging as well. So it can impact project timeline and even site logistics if we don't address noise during the design phase itself. And as a result of all of this, or as a consequence, there will also be issues with maintenance scheduling, because high levels of noise can indicate that there could be potential underlying issues with components, and that would necessitate frequent maintenance, and it can again disrupt the planning and the overall system availability. So there are issues with logistics as well. Then we have we have the impact in terms of electrical and structural integrity. So persistent noise and vibrations, it can weaken the structural integrity of the enclosure itself and the mounting systems over time. And as a result, it can, because of this continuous exposure to these vibrations, it can accelerate what we call as structural fatigue. So the enclosure and the base ends up weakening over time. And that means it could lead to a higher risk of component failure, and also thereby increase operational and maintenance costs as well. Then we have safety hazards. So again, I had briefly touched upon this as part of the ecological factors, but a lot of the times we have to ensure that there's adequate hearing protection involved, because prolonged exposure to high levels of noise, it can lead to hearing risks, especially for the workers who are working on the site. So it becomes absolutely essential that we ensure that all safety measures and protective equipment are being used. And because if they are not followed, and if the BESS installations do end up being above the safe threshold limits, it can lead to worker fatigue and miscommunication issues, and thereby a risk of higher number of accidents. So in all, it can become it's an operational risk, is what I would say, and it directly impacts performance, maintenance costs, and even safety. And lastly, we have component level impact. So if I have to break this down further, there are different components within a BESS system that can get affected by noise and vibration. So one of the first things that I had that ties in back to thermal management would be the cooling system itself. So the fans and the HVAC systems, the way that it's designed, if they're not taken into consideration, if they're poorly designed, or if they're just if they're not an important aspect of the design phase, it can lead to a poor quality of airflow exchange. And as a result, it can lead to a lot of turbulence, and as a result, lead to premature wear and tear. Similarly, the battery modules, the packs and the racks that are within the enclosure systems, if they are also not mounted properly, or if there are other components nearby that are not mounted properly, the vibrations that emanate or propagate from these kind of components can transfer to other components. And as a result, the vibrations can lead to microscopic levels of stress fractures, which might not be visible to the naked eye immediately, but it's a constant and slow process of wear and tear that happens over time. And then suddenly one day you're left with having to deal with more maintenance and operational requirements. Similarly, there are also other components such as the power electronics that form the inverters and the transformers. So again, AC chokes, the IGBTs, all these kinds of transistors, if a lot of them are designed to help reduce the harmonic distortion, but in some cases it can have a reverse effect, and it can lead to an amplified level of electrical noise, and that can again affect the inverter performance and the overall energy conversion efficiency of these systems. And similarly, again, if we don't look at the proper control and design of these systems, it can even lead to a looser connection of all the wires and the electrical cabling, and that can also damage the connections over time and lead to reliability issues and potentially even safety risks. So if all of these issues are left unchecked, it can sort of compound over time, and thereby reduce the system reliability and will lead to an increased level of maintenance costs that would have to be employed for such a system. So these are some of the reasons why we have to look at noise as one of the primary contenders in the design phase of BESS systems. So now that we know how it's important and why it's important, there's definitely good news, because there are quite a variety of solutions in terms of noise mitigation, and I have classified them into just a few of them over here, and one of them as what I call as viscoelastic materials. So now these are the materials that usually it's materials like rubber, for example, and anti-vibration pads, and what they do is they end up decoupling the components that exist within the system. So because of the type of material that we're using, it helps to dampen the vibration and absorb that that noise over time. And if there are any amplifications of noise as a result of this resonance, it helps to reduce that over a range of frequency, and that can lead to a quieter operation. So this mainly classifies as a material level improvement. And another important aspect in terms of material-based development is definitely the acoustically treated panels. So again, materials like fiberglass, rock wool, perforated materials, foam materials, these are different types of materials that can be used as paneling inside the enclosures that again help isolate the spread of noise, because it's not just vibration-related noise that matters, but also noise that transfers through air as the medium. So there could be different types of noise, such as high frequency noise and low frequency noise. And in many cases, these kinds of acoustically treated panels help in addressing these kinds of noise. And it blocks the transmission of this noise propagation throughout the rest of the enclosure, and that can also help reduce the overall impact of noise from a system level. Then we have what is known as aerodynamic optimization. So what I would classify this is as the computational fluid dynamic modeling. So CFD modeling often helps engineers to optimize a better airflow design or a better system design. So in many cases, if you're this type of approach helps us to produce a more targeted noise reduction design because we are able to identify where exactly the noise hotspots are. And this again ties back to some of the impacts that I had mentioned in the previous slide. So if there are any component level impacts or component level hotspots that we need to address, a lot of the times we can use CFD modeling to understand how exactly the component level noise profile would look like. And in many cases, we can use this targeted design modification to reduce noise. And at the same time, we are also able to look at better tech design, whether it's the fan placement or whether it's the number of blades that are being used in the fan, or just optimizing the design of the system itself. So all in all, this is a very proactive and a software-oriented approach to addressing the noise topic. And another important and upcoming technology that is still in the research and development phase is the active noise control strategy. So a lot of thought and a lot of research is currently going on in the market that surrounds this topic. So essentially, it's borrowing the idea of what we know as active noise cancellation headphones. So that we already have in the market. And what we're doing is trying to translate that kind of a technology into the BESS industry. So one way we can do active noise cancellation is through smart adaptive control or operational control, because the BESS systems do not have to operate at 100% all the time. We can take advantage of periods when there are lower operational profiles or operational loads. So that's one way. And by introducing an active smart control system, we are able to dynamically adjust the operation without much human interference. But at the same time, there's also the actual technology itself that is being researched and developed, that is the active noise cancellation technology. And essentially what it does is that it uses microphones to pick up ambient noise, and then it generates sound waves that are exactly opposite to that ambient noise. And when the detected noise and the ambient noise, when they're opposing each other, it helps to effectively cancel each other out, and then it reduces the overall level of noise that we get from the system. So again, it's a very targeted approach and a very software-driven approach, but ultimately it helps to reduce the noise from a component level perspective rather than looking at the entire system. Then another approach is definitely what I call as soundscaping the site. And this is something that we at Wärtsilä we actively do. So what we use is a noise modeling software that helps us to identify what the noise would look like, or the sound propagation would look like for a particular BESS site. So we use strategic site layouts. And again, depending on all the previous noise mitigation strategies that I had just mentioned, we can use a combination of all of them to identify how exactly the noise is traveling, if we are having exceedances, and if we are having exceedances, how can we mitigate the noise using some of the hardware and software related approach. So in many cases, doing a noise mapping or noise modeling in the design phase or during the project planning phase helps us to again target the noise topic and helps us to make sure that we are within the reasonable noise limits that is proposed, not just by the regulations, but also by the involved stakeholders as well. So I believe that this is definitely one of the more active solutions that can be employed currently, and it is something that we also take pride ourselves in doing, and it's one way that we help support our customers as well. So now that we've looked into the solutions, I've also wanted to help you all visualize what this would look like in practice. So this is a sample noise modeling or noise mapping case example. So in order to give you a background, let's consider a utility scale BESS installation that is in a commercial area. So when we talk about commercial areas, we can expect that there would be some level of community impact or some level of people living nearby. So we have to ensure that the noise levels are within the reasonable levels. So what are some of the challenges that we could observe from the site? So one of them is definitely noise exceedances. We might potentially exceed the levels proposed by the regulatory authorities. And as a result, we would be subject to regulatory non-compliance. And if not addressed, if the noise mitigation is not addressed, this would translate to heavy fines. And at the same time, because this is still in the initial stages, we might consider operating the system at 100% capacity. And that would mean equipment stress because, again, as I mentioned earlier, we don't necessarily have to operate it at 100% all the time. And of course, with the site being near a commercial area, there could be health and safety risks, all because of the other challenges that are present on site. So what would an initial analysis of such a site look like? So one of the first things that can be done is to ensure that we have the recorded noise levels of all the equipment involved. So whether it's the battery enclosures, whether it's the inverters or the transformers, making sure that we have adequate noise data is absolutely important. And then what we would do as a result is feed this noise data into the noise mapping software and understand how exactly we can translate this into a site level analysis. So to give you an example, for this particular site, I'm using arbitrary numbers, but at the same time, these numbers do represent what the site level noise boundaries could look like. So if I have to give you an example, at the site boundary, the noise levels should be 40 decibels, but the simulated results at this stage during the initial analysis might show 45 decibels. So it means that we are significantly above the noise levels, and this could potentially lead to the challenges that I had mentioned above, such as regulatory non-compliance and community impact, so on and so forth. So what are some mitigation strategies that we could employ? So one of the things that we could look into is the use of silencing kits or noise attenuation kits, which again, as I mentioned before, they comprise of acoustically treated panels and materials that could be fixed onto the equipment. And as a result, it helps to lower the overall noise profile of the equipment itself. And if we lower the noise level of the equipment, it would mean that we could expect a lower noise at the site boundary. Similarly, we could also look into another mitigating strategy of noise control in terms of operations. So we don't necessarily have to operate the fans at 100%. Maybe during the nighttime, it does not require such high levels of fan operation because the temperatures might be low or the ambient conditions might be more milder. So as a result, we could play around with operational control and fan speed control to lower the noise. And similarly, another mitigation strategy would be to also potentially install acoustic barriers around the enclosure. So this would be more viable if we install it closer to the noise hotspot areas. So for example, if the community or the commercial areas are towards the east of the site, it would make more sense to look into noise walls that are placed on the east of the enclosures as well, so that they can help absorb some of the noise that is propagating from the equipment. So in many cases, only one or a few of these mitigation strategies are needed, but in other cases, again, depending on site-specific challenges, we might have to employ a plethora of strategies, but ultimately these are just some solutions that we can employ on a high level and that industry does employ in terms of noise mitigating solutions. And what this would translate into in terms of results would be a significant sound level reduction. So initially we were at 45 and now we are at 38. So we're not just below the noise limits of 40, but we are below the noise limits with considerable margin. And personally, it's always a safer option to ensure that the noise levels are below with a certain margin, because it helps account for any uncertainties, measurement uncertainties, and even modeling uncertainties. Because at the end of the day, no matter how accurate the noise modeling and predictive approach is, it could still lead to, it still cannot represent the real world conditions at the exact same level. So there's always going to be some level of uncertainties which should be considered, and this helps guarantee that the noise levels would be compliant. So that now we're slowly coming to the end of the presentation. So essentially, to wrap up, I want to emphasize that noise is not just a regulatory concern at this point, and it is absolutely important to understand that it has a direct impact on the efficiency and the reliability of the BESS systems. And if we keep treating it as a secondary concern, then it can lead to significant issues with planning and project delays. And as a result, it could lead to even component failure over time. And another important aspect to look into is the importance of data collection. And this is something that I would like to highly stress on, because proper data collection and noise mapping is absolutely crucial to ensure that we optimize the acoustics of the system. Because a lot of the times, if the data is not accurate, then that would mean that we do not get an accurate mapping of what the noise would look like. So being up to date, doing constant noise tests, and doing it continuously and frequently would ensure that the equipment is also reliable and safe and consistent. And it also gives a guarantee, sort of like a quality control check, as to the fact that everything is okay, and that the noise levels are also pretty consistent with one another across multiple units. Because noise is, it is a project killer, and nowadays it's again one of the most important topics that is being discussed. And as a result of that, the industry is slowly seeing a change in the trend, and a lot of the a lot of research and development is being put into innovative noise mitigation strategies to ensure that there's better efficiency and compliance. So addressing noise at the end of the day is not just about meeting regulations, but it's about enhancing the overall system for better performance, and ultimately have a sustainable solution that impacts everyone in a positive way. So that's just a brief and a key takeaway of today's presentation, and I hope that it was an insightful session for everyone involved as well. And that basically wraps up my my time, and thank you so much for listening in. And I hope that this session has been able to shed some light on the importance of acoustics and energy storage. So thank you, and yeah, I would be happy to take any questions that you might have now.
Thank you very much, Sharon, for your presentation. So there are quite a few questions here. Let's start with the first one, which I think is very relevant for project development. So Guillermo Chavarria asks, is it possible to integrate firewalls with noise barriers? In countries such as Italy, firewalls have become a requirement for BESS projects.
Mm-hmm. So I guess this question has to deal with fire safety related issues. And if I'm not wrong, if I understood it correctly. So again, it is possible, because as I mentioned before, there's a lot of research being put into material related R&D as well. And we're seeing a lot of new types of technologies and new types of materials that are being employed. So materials that involve some level of nanotechnology and some level of improved chemical design or chemical composition. So maybe someday we might be able to integrate both fire safety and noise as one solution in terms of, treated panels. But today, at this point of time, there's still a little bit of a divide, I would say. So a lot of the times when BESS sites are designed, we have to take into account that they're not encroaching on fire fire protection zones, or we have to ensure that the BESS sites are within the fire protected zones. So again, that could again tie back into site level constraints, but overall, it is a potential solution for the future, I would say.
Okay, thank you.
Yeah.
There are a couple of questions that are related to the levels of noise that are required by regulations. So could you give us an idea of the ranges in which the regulations start limiting noise coming from BESS?
Mm-hmm.
So what kind of
So
decibels or
yeah. So this is a bit of it's a very good question, but it is also a little bit difficult to answer, primarily because it is, I would consider this as one of the biggest challenges. So when we talk about noise levels that are expected in different regions, a lot of the times the noise topic is not governed by a standardized body. So for example, the EU will have a different level of requirement, and even within the EU, each country, each state would have a different requirement. So there isn't a standard decibel level that we would have to reach. We oftentimes have to meet the local regulatory requirements. Similarly, for example, in Australia, the noise levels can get even more stricter. So on average, I've seen numbers like 34 dBs or 40 dB decibels, and in some cases even lower than that. So on average, as we move closer to densely populated areas, the stricter the noise limits. So it all depends on where exactly the site is, but on average we can see a range between 30 to 60 decibels as an average level of noise required.
so
Yeah.
for the lay people like me out there, so what sort of volume is a normal conversation?
So a normal conversation is just 40 to 42 decibels. So
40,
we're
right?
talking about, yeah.
So if they want
The
it below
conversation,
30, then they want it to
exactly.
basically
Yeah.
be entirely silent.
Exactly. So the conversation that we are currently having between you and me, I would say it's around 40, 45 decibels. And
Right.
what they're expecting is a quieter solution. They want it to be absolutely silent because that's what we want to prove to the community as well. And it's completely understandable why they're so strict, but it also shows that the need of the hour is that we have to address them no matter what. Otherwise, it's gonna affect multiple areas.
Okay.
Yeah.
It makes a lot of sense. So someone asked, actually, Raphael Hersberg asks, are decibelimeter apps, so mobile apps, good enough to measure noise, or are they really not reliable?
I would say that for maybe day-to-day understanding of noise, mobile apps would help. But when we're looking at equipment level noise testing, we do have specific materials for that or equipment for that as well. We have sound level meters, and we have specific and very sensitive microphones and preamplifiers, which cater towards these sensitive noise tests. So it would require a whole other level of equipment usage. But the reason why that's also important is because even when we look at it from a regulatory point of view, there are certain standards or classes within which the testing should be done. So we have to ensure that the equipment we use to record noise levels are within class 1 of a particular standard. And in order to do that, we have to invest a little bit in the equipment we use. So in many cases, when we look at, not in many cases, it like the industry standard is that we have to rely on sound level meters, and maybe mobile apps might not be the ideal solution for that.
Right. And through some of these webinars we have done, I have actually learned that noise, the way it propagates is more from a BESS system, is more complicated than it seems. So it's not
It is.
equally distributed around the system. So yeah, I'd say, if you want to do it properly and do it professionally, and a mobile app is not going to cut it.
No, and in many cases, it would not be accepted by the regulatory bodies as well. So again, because it's such an abstract topic, noise is very abstract, and even the slightest change in, let's say, the wind conditions or the humidity conditions and even temperature, it can have a significant impact on how the noise propagates. So we can clearly see a difference from, let's say, day 1 to day 2. So it gets absolutely crucial that we take into account all of these factors, and so we might as well do it with proper equipment.
Yeah.
Yeah.
So you mentioned an interesting thing that I had never thought about, which is that there is the noise coming out of a system can cause stress to the other components and the structure. Yeah, that makes complete sense. And I suppose that noise is a form of energy as well.
Yeah.
And someone asked here if you know of any studies that indicate how many years uh, do have to pass before we see stress factors due to noise showing in BESS systems.
So that is again very subjective because it really depends on how the system itself was designed. But what we can say from our side, at least, is that since we take the noise topic very seriously, it is one of our quality control procedures that we employ within our company, and we do consistent checks because, in a way, as we had explained, as we discussed, it is often an indication of if everything is going all right within the system. So a lot of the times it's a bit difficult to say for existing systems because the noise topic was not a problem. The whole discussion surrounding noise became a big question only within the last 1 to 2 years. So before that, noise was not really important. People weren't really talking about this. So none of the systems that were designed before this time would have accounted for that. So it's a bit hard to say what the duration as to when we can expect to see the effects of noise, but I would say that on average, maybe in like 3 to 4 years would be a good number to estimate if things are a bit awry or not.
So
Yeah.
it's sort of like an area of that is still being explored, right?
Absolutely. It's very much a recent development, but a development that is happening at a very fast pace, and it's become very important over the span of just 1 to 2 years. So, yeah.
Sid Pandey asked 3 questions in one, so let's look at them one at a time. So are there any noise dampening solutions available for BESS, particularly low frequency noise? So I think you talked about some of those solutions in your presentation, Sharon.
Yeah.
So tell us a little bit more about low frequency noise and what is that? What is the difference between low frequency noise and other types of noise? And is there noise dampening equipment or solutions to tackle
Yes, so
this?
it is definitely a very good question. So the difference between low frequency noise and high frequency noise can also have an impact on what kind of solutions we use. So to give a sort of an example of what this would look like is that you all might be aware of radio waves. So if there's a radio station that is a couple of hundreds of meters away, we can still hear it at a larger distance because low frequency noise ends up traveling over time, and it is a type of noise that is much more difficult to attenuate. So we have to look at very specific material related solutions. So again, I had mentioned some of them in my slides, but it all comes down to the type of material we use, whether it's, for example, rock wool or perforated materials. There are a lot of solutions out in the industry that specifically treat low frequency noise dampening. High frequency noise, however, is much more easier to dampen because they die out very easily over even shorter distances. So in many cases, if you're able to also convert the low frequency noise sources to higher frequencies by, let's say, for example, changing the fan design, it then becomes easier to attenuate it by using maybe a much more milder mitigating solution. So I would say that the types of solution would ultimately, at the end of the day, vary, but on average, there's definitely a lot of options out there in the market. But I would start with acoustically treated panels and look at those.
Okay, so also on the same sort of like bunch of questions, Seed Pandy asks, have you come across any project where fan blade change was needed to improve noise from BESS chiller slash fans? Do you know any?
I have come across some projects where we could do that, and as a result of that, we've what we've understood from the industry and from a very high level is that hardware change did lead to a lower noise output. So definitely, when we look at hardware related improvements or material related improvements, they do have an impact in addressing the high levels of noise. So yeah, absolutely, it is possible.
Okay. Then
Yeah.
finally, he asks whether there are acoustic kits available for BESS. And I think I could answer that one. It's probably yes.
Yeah,
So,
absolutely. Because the acoustic kits, they not only exist for BESS, but now because a lot of people are now talking about noise, even inverter suppliers, they all also have acoustic kits as well. So it's become a standard, an industry norm, or like a standard solution that could be added as an optional add-on if required, because noise is now such an important topic. So absolutely, yeah, there's a lot of solutions out there.
mhm. Okay. Um, let's see. So, there are a few questions here on that are related to the equipment. So Chris Tassis asks, are you familiar with BESS systems with centralized HVAC mechanical systems or isolating the HVAC equipment into a centralized building? So I suppose where this question is coming from is that, I mean, as far as I understand, a lot of the noise comes from the fans. A lot of the fans are in the HVAC system. So um, is this a thing that you have seen that at the design level, someone thinks, okay, so let's use centralized HVAC, and then maybe that could be, further away the from populated areas or sensitive areas, so you don't have to worry so much about making a little bit more noise.
Yeah, I completely agree with you because I mean, right now we do not, I don't, at least in my experience, I haven't seen any projects that use a centralized HVAC system. But I have heard about this solution sort of flying around, and I think that there is again potential for this because now we're sort of localizing the noise source into just one system instead of multiple ones. And again, if we look at strategic site placements, we can kind of, depending on how exactly we design it, we can place it away from more sensitive receptor areas or more high impact areas, and as a result just focus on reducing noise for that one system instead of doing it for multiple units that exist within the site. So I definitely think that there is merit in that option, but personally for me I haven't seen that solution in practice or in installation up until now. So maybe in the future we can look into it.
Yeah. Okay. Team Ryan asks, or says, it would be great to hear your thoughts on fitting silencers with BESS units to reduce airborne noise to the environment. I don't know what he means with when he talks about silencers. What do you know what he means?
I think he's from what I understand, he might be asking what is the impact that we can see from silencers that are used to mitigate airborne noise. And again, that is a solution that currently does exist in the industry, and I personally have seen quite a significant noise reduction from such a solution. And on average, if I have to give you a range, I've seen around a 3 to 4 dB reduction because of the silencer add-on. And especially if it's designed well, definitely we can get a significant impact out of it. And it is a viable solution, and it is a solution that is being currently employed in the industry as well. So there's definitely a use to that option for sure.
Okay, great. So there is some people talk about artificial noise cancelling. Others have made questions about the challenges to using active noise cancellation. So let's read the first question. So does artificial noise for noise cancelling have any impact on tonal frequencies? So any thoughts on that?
So tonal frequencies, again, would generate from, again, equipment level noise. So artificial, for example, if you look at, if you're talking about artificial intelligence-based noise control, it might not necessarily have an impact on tonality all the time. So it can have an effect on tonality for maybe certain levels of operations. But if you're looking at active noise cancellation in terms of the technology itself, then yes, it can have an impact in addressing tonality, because again, it can be used to cancel out certain ranges of frequencies. And when we cancel them out, we're also talking about minimizing the effect or the intensity of those specific frequencies that are propagating over a certain distance. So again, it's a multifaceted approach, but I definitely do think that depending on what kind of solution we're going for, we can see tonality improvements with this technology for sure.
Okay.
Yeah.
Great. So on the same topic, Isaac Chu asked, what do you think are the current major challenges with using active noise cancellation, and why?
I would say just the whole process of implementing itself. It is a technology that is mostly beneficial for indoor applications. And when we look at BESS sites, they're definitely more outdoor. So there are a lot of extenuating factors that come into play. So again, I briefly mentioned this in one of my previous answers, but conditions like wind, temperature, humidity, and the presence of maybe other reflecting sources. If for example, if there are other buildings nearby, they all can contribute to noise enhancing or noise dampening effects. So and outside on a field, noise can be very, very multi-directional. So that's where ANC technology or active noise cancellation technology can be a bit challenging, because it's mostly focused over it's very directional based approach in terms of attenuating the frequencies. So when we take it out on the field, and when it becomes multi-directional, and when it spreads across a larger area and over in a more concentric manner, it can get very challenging to maybe address it all at the same time. So right now, I think the effect is trying to translate it into outdoor-based applications.
Okay. Right. So we have only a couple of minutes left. Maybe let's take the last question. So Santos Garcia Rosado asks, from an acoustics perspective, is there an advantage of using liquid cooling systems versus HVAC?
Absolutely, because then we are reducing the reliance on fans. So that would mean that, I mean, there will still be some level of fan usage as well, but we're relying more on liquid-based cooling rather than air-based cooling. So because of that, we can see a significant reduction in the noise levels as well. Absolutely, there is, and I believe that there are a lot of industry BESS integrators out there in the industry, and ourselves included, that we're shifting more into liquid-based cooling to address the noise, high levels of noise, and in a way get lower noise impact. So
Okay.
yeah.
Right. So, well, maybe we do have time for one more question. One that sounds fairly straightforward. Maybe it is, I don't know. But Danielle Bravo asks, how much dB is it really realistic to mitigate using sound mitigating panels?
So could you repeat that once again?
So, how much dB? So how many decibels could you
Yeah.
lower the sound, the noise with sound mitigating panels?
So again, this would highly depend on how exactly the mitigating panels are placed. So are we looking at it from a site level installation, or are we looking at it from an equipment level installation? But on average, I would say, again, the minimum amount of improvement we can get is 2 decibels or 2 dB, but the maximum it can go up to 4 to 5 dB. So
Okay.
it all depends on how exactly we place it. So
Right.
again, it becomes, it's not a one size fits all approach. So we have to look into multiple aspects for each specific installation. So it's not always going to be installed in the same way for each project each time, which is why it's a bit difficult to give an exact number. So for now, averages would have to do so. 2 to 5
I can
dB
understand.
improvement is what I would say. Yeah,
That
thank you.
sounds that you need, if you really need to lower the decibels, the noise level significantly, then you need to look at more, like a number of things, right? Not just one
Yeah.
solution.
Exactly. Yeah.
So changing equipment, panels, placement, barriers, all sorts of things. So, okay, that
Yeah.
makes a lot of sense. All right, Sharon. So thank you very much for today. So we are about to we should bring the webinar to a close now. Any parting words for the audience?
Yeah, I just would like to thank you all for your time and for taking a little bit of time out of your day to come and attend this webinar. And ultimately, my intention is to sort of create a dialogue and have this engagement and knowledge sharing experience with one another, so that we can start talking about noise more actively and take it more seriously. Because up until now, it's become it's always been a secondary concern. It's not really been the primary point of focus. It's just been an interest over the last couple of years. And because of that, again, with the fast-paced industry, we have to keep up and ultimately work together in many ways to ensure we're proactive about it. So that would be my parting words. And yeah, thank you all for your time.
Thank you very much, Sharon, and thank you all the audience for being with us today. Remember that you will get the video recording and the slides in an email. So thank you very much. And